Here is our final part assembly, putting together all our different part segments and purchase parts together to reach our final assembly. This assembly consists of our final base piece, our arm segment 1, arm segment 2, arm segment 3, our syringe housing, the plunger used in it, the male lure that is glued onto it, and a model representing our ball joint tripod mount, along with many McMaster parts, including here can be seen our friction hinges. You can see our M6 heat inserts, our 16 millimeter our 16 millimeter M6 screws, our 10 millimeter M6 screws, and our 1/4-20 inch heat insert, as well as a few other hidden parts that will be displayed once we open our exploded view. So here we go. I go here and I toggle the exploded view. We get this. You can see all the part segments separated, and the hinges, screws, and heat inserts all shown exploded away from where they are set into. The heat inserts set into this hole, the hinge set on the face of the segments, and the screws connecting it all together can be seen here where my cursor is, and again here where my cursor is. One of the other parts that wasn't able to see before is this thread adapter that we use, which is M6 to 1/4-20 thread, connecting our arm segment and heat insert to our tripod ball joint. Altogether, this allows us to see how our assembly all comes together in the real world building phase and how all the parts are hidden within it. Now, to get to our mates. Actually, before the mates, I'll go through our inventory. We have, which will better be seen through our exploded view. We have two of the M6 16 millimeter long screws. We have 8 of the 10 millimeter M6 screws. We have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 M6 heat inserts, 1 thread adapter, 1 1/4-20 heat insert, 1 tripod joint, and 2 friction hinges, along with our 1, 2, 3, 4, 5, 6, 7 different 3D printed parts. That is our inventory. Now, most importantly, to see how it all comes together, which will be displayed with our mates. I will go through all the mates we have here to see what their purpose is. To show you in advance, I made it such that in this assembly, all of these parts are fixed so that the whole assembly is fully defined. To do this, any rotatable piece, which include the screws, the heat inserts, the thread adapter, any of those pieces, I used these parallel mates to make them parallel to whatever corresponding plane of the assembly was necessary to make them fixed. I'm not going to be specifically covering those as they have nothing to do with the actual assembly of the part itself, but as we pass by them, I will hover over them and you can see that they are used to constrict the movement of that part in a way that shows that all of these parts here do not have a minus next to them. First, we use a coincident mate between the top face of our base piece and the bottom face of our arm segment 1, along with 2 concentric mates between two of the different pegs and the peg holes, allowing it to be that the faces are touching, and with two concentric mates between the pegs, there is no rotation at all with this part. Next, I put concentric and coincident mates for both of the M6 heat inserts inside of the hole cut out for them in arm segment 1. They're coincident to the back face here, and they're concentric to the hole, along with using perpendicular for the constricting to the planes. Then I used concentric and coincident mates for both of the M6 by 16mm screws, making them concentric to the hole that they go through, which is fully aligned with the the heat insert holes, and screw in properly. And also used coincident mates to place the bottom face of the screw with the front face of the ledge on the base piece that is used to leverage the pieces together, along with parallel mates for constricting the part. Next, we use concentric and coincident mates along with parallel for constricting the movement, with concentric mates and coincident mates for the M6 heat inserts for the connection between arm segment 1 and arm segment 2 on the that is seen on the adjustable friction hinge. You see that concentric, coincident, parallel, concentric, coincident, parallel, and then we made the face of the hinge coincident with the face of the ledge, and as you can see, the edge where they both meet is completely aligned, which, as described in our part videos, is why we used the assembly for reference drawings in the individual parts. You can then see that both screw holes are made concentric with the holes for the screw holes on the hinge with the inserts, so they're fully aligned, and then also making concentric, coincident, and parallel the M6 by 10 screws that connect the hinge to the extrude. And then the exact same thing can be seen here for the heat inserts and the screws on this arm segment 2 connected to the now fixed arm segment 1 and hinge. So this whole thing is being built from bottom up. Then using, again, parallel, more parallel and coincidence to make the bottom face of the screws be touching the front face of the hinge, etc., etc. Now, let's go up here. We repeat the exact same process up here with arm segment 2 and arm segment 3. We have concentric, concentric, coincident, concentric, concentric, coincident, concentric, coincident. And I believe the parallel ones for these can be found farther down, but it's unimportant. The point is here, I'm not going to dive too deep into these mates as they are exactly the same as the one I just went over, with the 4 M6 heat inserts being made concentric, coincident to the bottom face of the cut holes in the cut 8.75mm diameter holes in the arm segments. Same thing happening with the screws being made concentric with those holes and coincident with the top face of the hinge, and the hinge bottom face being made coincident with the face of the extrude on the arm segment, so that it all is properly aligned, as well as the concentric mates between the holes of the hinge and the holes in the arm segment. Then we can move forward to here. This time it's only one mate between one heat insert in the hole for our arm segment 3 that will eventually be used to connect it to the tripod mount joint, as can be seen here. We use one more concentric, coincident, parallel. Then separately, I put together the syringe housing and plunger. So see in the exploded view, we have these separate pieces, and the plunger and the lure lock piece needs to be made concentric and coincident, and that is how they are superglued onto each other in real life. After that, we make the plunger and the syringe housing hole concentric, and later we use a distance mate. This is, in real life, this will be constantly pushed and moved around, but the reason I'm using a distance mate here is to lock down the part in a preempt before using stage, so it's not fully inserted yet, to demonstrate function, but in a real part, in the real life usage of it, it will not be constrained. Where were we? Okay. Then we have a coincident mate for the 1/4-20 heat insert, which conveniently fits in the same 8.75 millimeter diameter, 8 millimeter deep hole, along with concentric mate. And a later parallel is one of these here. Then okay, yeah, these are more of the concentric mates that are used on the hinge here. I apologize that some of this stuff is not in order because different parts of it were assembled at different times. So here, I already went over the coincident and concentric mate here, parallel, but then a concentric mate and coincident mate is made between the bottom face of the tripod mount joint and the outward face of the end of arm segment 3, as well as a concentric and coincident mate is made between the outward face of this connector on the syringe housing to the screw and face of the mounting place on the tripod mount, as you can see here. This is where they're connected with the threading here. The more parallel mates, distance mate, perpendicular, parallel, and parallel. And I believe I have skimmed over. Yes, here it is. This is the concentric and coincident and parallel mate for the thread adapter, right above the concentric, coincident, and parallel mate for the tripod joint itself. So altogether, these are all the mates that were used. Almost all of them are either parallel or perpendicular mates for planes to constrict their movement, concentric and coincident mates for putting a screw or insert into squarely within the middle of the hole it's meant to be on, as well as putting it up to the face it will be touching, and a few other uses of concentric and coincident mates that demonstrate how the entire assembly will be actually created in a real world setting. Thank you.